This is proof that the Goldbach conjecture is true. Every even number within infinity is the sum of two primes. The beauty of this absolute rigorous mathematical proof by elimination is its simplicity and the fact that we do not need to know anything about the locations of individual primes.
Let x be an even number.
Every odd number under half of x pairs with an odd number above half of x to sum to x. An odd number never pairs with an even number, so we can eliminate all non-prime pairs using the sieve. So by doubling the primary sieve to remove all multiples of primes less than the square root of x, which is x divided by two odd numbers, less a third, less a fifth of the remainder, less a seventh of the remainder, less 1/11th of the remainder, etc. Remove double the amount of odd numbers to remove all multiples of primes less than the square root of x and the odd number which they pair with and sum to make x, which is x divided by two odd numbers less 2/3, less 2/5 of the remainder, less 2/7 of the remainder, less 2/11th of the remainder, etc. So the only odd numbers remaining must be primes and in pairs of locations which sum to x.
The only way we could have an exception is if the fractional deductions of composite numbers made from primes less than the square root of x catch up in number and eliminate all primes added since the previous highest value of a prime less than the square root of x, ph. This, however, is impossible because the extra fractional deductions decrease exponentially in their ability to remove primes, while the number of primes grows incrementally, only halving in primes per integers with every doubling of integers. For example, at only the 10,000th prime, which is 104,729 squared plus 1, we get x is 10,968,163,442. There are 5.5 billion odd numbers, and here the sieve eliminates 99.91521985% of all odd numbers, including primes. However, that still leaves a whopping 26.5 million primes, giving 23.25 million prime pairs, and in mathematical terms, that's a tiny number.
Because the only odd numbers left after such fractional deductions must be primes, and because they must be in locations where they pair and sum to x, and because the number of primes less than the square root of x grows slower in proportion to the number of new primes, it means the fractional deductions of multiples of primes less than the square root of x is always outpaced by the number of new primes, as the value of x increases, always ensuring there will be more prime pairs as the value of x increases towards infinity. So the Goldbach conjecture is definitely true. Given that this is one of the most famous mathematical conjectures in history, which has eluded some of the greatest mathematicians of the last 300 years, it is likely that many more mathematical problems, which are currently revered as infamously difficult, may also have simple solutions, which may also be solved by novice mathematicians like myself who are able to think outside the box to apply solutions which are simple but may not be so obvious or intuitive. This and my absolute proof by elimination that a second loop is impossible in the Goldbach conjecture are both condensed into 1 minute shorts available on my channel YouTube Breaking Physics Beyond the Standard Model and odyssey.com Science Not Dogma.